So now let's talk about another more common problem. Now, what if I was really far off? I was extremely far away from you. Now, what will happen? Now, you again will not be able to see me properly. So this is a different case because I'm a large object, and because I'm far off, the angle that I subtend at your eye, or the image of me that is formed on your retina, is extremely small. So therefore, you can't see me very clearly. So what will you do? You will probably use a telescope or maybe a pair of binoculars. So when you use them, you suddenly see that, or you suddenly feel like I've come much closer to you. How exactly does this work? So telescopes are also made of two lenses, two biconvex lenses, one called the objective and one called the eyepiece. Now, the only difference here is that the objective has a larger focal length and the eyepiece has a smaller focal length. We'll come to why in some time. So what happens is, the objective receives pallid rays because the object is extremely far off, so it's almost at infinity. So these pallid rays are focused by the objective, and it forms a real inverted and diminished image. Now the thing is, the eyepiece is placed in such a way that this image is formed at the focus of the eyepiece itself. So therefore, the eyepiece forms a virtual, inverted and magnified image of this particular image. Why? Because this image acts as an object for the eyepiece, right? And why is the image inverted? Because this image also is inverted. So as I said, you finally end up having a virtual, inverted and magnified image. Now, if you see, you can see that the angle subtended by this image at the eye is greater than the angle that the object subtended at the eye. So therefore, this is why when you see through a telescope, it looks like the object is much closer. And that's how telescopes work.
Hey Avinash, all beautiful, but I have a doubt. You know, microscopes and telescopes have almost similar working, right? They both have two converging lenses and two-step image formation, then magnification. But we had two versions of a microscope, a compound microscope and a simple microscope, I remember. Why don't we have a simple telescope?
Okay, so why no simple telescope? Let's see, so what do we need for us to achieve what a telescope does with a single convex lens? So we need to create a magnified image, a magnified virtual image of the object with a single lens. But to do that, the object has to be within the focal length of the lens, right? So, and in this case, we are dealing with objects that are really far, like stars, for example, which are a few light years or millions of light years away. So to create a virtual image of a star with a single lens, you will need a lens that has a focal length of a few million light years. So that is just physically and practically impossible. And that's exactly why you don't have a simple telescope.